Okay, welcome. Today we're going to continue on solving trig equations. Today we're going to look at solving equations with multiple angles. Now, we can tell if the equation has multiple angles by simply looking at the argument. Up until now, all of our arguments have been a simple x, a simple variable. Now we're going to start adding coefficients on that variable, and that indicates we have multiple angles. Okay, let's go ahead and write this problem down in our notes. We're going to find the solutions, or all the solutions, of 3 times tangent of x over 2 plus 3. Okay, and that's equal to 0. So the first thing we want to do is we're going to take care of this, or rewrite this, without the multiple angle. And we're going to use a simple u substitution. Now, a lot of people get confused over what a u substitution is, and it's simply taking this expression x over 2 and we're rewriting it as just a single u. And the purpose of doing this is simply making it look like something we know how to do. And at the very end, we'll substitute back in the x over 2. So again, the purpose is rewriting this and making it look like something we know how to solve. It just makes it look easier. So we have 3 times the tangent of u, remember tangent is x over 2, so it's identical, is equal to 0. Now this is a linear type equation, it's to the power of 1, and we simply handle those by isolating the trig function. So I'm going to subtract 3 and divide by 3. When I do subtract 3 minus 3 and divide by 3, I get negative 1. So tangent of what angle is equal to negative 1? So if I think about that, tangent, so I'm going to do a quick sketch of my unit circle. I know tangent is positive when the signs are the same, and it's negative when the signs are different. And the signs are different in quadrant 2, and, oops, I reversed these. This is negative positive. So let's just kind of erase that and do that again. So again, with the unit circle, it's a quick sketch, really rough sketch. When I look at sign analysis, the signs of my points, I know x is negative, y is positive, so that implies that tangent will be negative in quadrant 2, and I know in quadrant 4, x is positive and y is negative, and that implies tangent is also negative in quadrant 4. So when I'm looking for tangent is negative 1, I'm looking for angles in quadrants 2 and 4. Okay, so I know tangent is negative, so I got to do a little thought process on this. That's when my sine over my cosine are exactly the same in terms of, or sorry, not exactly the same, they're opposite numbers. Okay, so same numbers, opposite sides. And I know that happens at our pi over 4 angles. So I can say that my u is equal to the pi over 4 angle in quadrant 2, which is 3 pi over 4, and my quadrant, or my pi over 4 angle in quadrant 4, which is 7 pi over 4. So there's my two angles that u is equal to. Okay, so our next step is we're going to substitute back in our u. And we know u is equal to x minus 2. So with a simple substitution, I can say that x over 2 is equal to our first angle, 3 pi over 4. And again, because we are not in a specified interval, I have to tack on our pi in. Remember, the period of pi is tangent, different than sine and cosine, so this one's pi. And our other angle is, well, let's write them over here, x over 2 is equal to 7 pi over 4. And again, not a specified angle, so we want our general form, and that's plus pi in. Now, so far, nothing's changed in our solving other than we made it look like something we know how to do with a u, and we just substitute it back, but solving's still the same. here's where it changes. Now I have to solve for x. So what I need to do to solve for x is to multiply each term, including the pi n, by 2. So I'm going to rewrite this as exactly what we see here. And I'm going to multiply everything by 2. So that by first term by 2, the pi over 3 by 2, and our pi over n by 2. And we can see this goes away. I'm left with x is equal to, now this would be 3 pi over 2. I know 2 goes into 4 2 times. This is 3 pi over 2 because it's been reduced, plus 2 times pi n is 2 pi n. And there's our first solution. Okay, our second solution is, now this is a pi over 4 solution. And if I really think about that before I go any further with this problem, I always grab my 2 solutions. But remember, the period of tangent is pi. So if I'm up in this quadrant, which is our 3 pi over 4, I know that if I add pi to it, which is halfway around, I'm going to pick up this 7 pi over 4 angle. So my 7 pi over 4 angle is embedded the second I add pi over n into this first equation. So what it means is I don't need to solve for this because it's picked up when the value of n is equal to 1. When I add pi to 3 pi over 4, it'll give me my angle. So I am done solving at this point because I have every single angle that makes this equation true written right here in this form. And I apologize that I didn't catch it in the beginning. So that's one I did not need. Okay, so that being said, if you have any questions, please jot them down on the side and we'll handle them in class. Thanks.